Nomenclature of amides and cyclic amides. Nomenclature of amides. Amides are obtained when the OH in carboxylic acid is replaced by one of these groups, by NH2 or NHR or by NR2. Okay. When you replace it by these two, it's going to be a substituted amide. Let's take a look into the IUPAC names. The IUPAC names are going to end with amide. Now for the first compound, you do have two carbons, and therefore it's conveniently called as ethanamide. Ethane plus amide, ethanamide. Right? And for the second compound, we do have 1, 2, 3, 4 carbons, and therefore this should be a butanamide. But we do have a chlorine that's present on the fourth carbon. So this carbon would be number 1, 2, 3, 4. Since we have a chlorine on the fourth carbon, this should be called as 4-chlorobutanamide. Make sure that you put all these together. And for the next compound, whenever you have the amide group that is directly attached to the ring structure, then you're going to use the suffix of carboxamide. Carboxamide. Okay, so this is carboxamide. This part right here is called as carboxamide. And you have the benzene structure. You have the phenyl structure, which should be called as benzene carboxamide, just as you call benzene carboxylic acid. Let's go on to the common name. This compound, ethanamide, is called as acetamide. For this one, we needed to give the Greek alphabets. This would be alpha position. Remember, the carbon that is adjacent to the functional group is going to be alpha. So this is beta, this is gamma. So this would be gamma chloro. And here you will not be using butanamide. Instead, it will be butyramide. Butyramide. And next for this compound, this will be simply called as benzamide. Here are some examples for substituted amides. When you wanted to name the substituted amide, then you have to name the substituents that is present on nitrogen first. Let's take a look into this molecule. So you have a cyclohexyl group on it. So this should be stated as N-cyclohexyl, right? And then you're also going to find out the number of carbons that is present in this part of the molecule, which is coming from the carboxylic acid. So totally there are 3 carbons. So therefore it should be propanamide. Propanamide. Okay, now let's take a look into this molecule. In this molecule, you have 2 substitutions on this nitrogen. You have a methyl group and you also have an ethyl group. So in this case, you're going to call this as N-ethyl, N-methyl, right? Because E comes first and then comes M. You cannot write it as N-ethyl methyl. That would be different. That would be wrong. Okay? And then you're also going to find the number of carbons that's coming up from the carboxylic acid. So 1, 2, 3, 4, 5. So there are totally 5 carbons. Therefore, this should be pentanamide. Let's go on to the next molecule. The next molecule is also having 2 substitutions, but both of these substitutions are one and the same, right? So in which case you're going to call this as N, N diethyl. Diethyl followed by the suffix. The suffix here is 1, 2, 3, 4. There are 4 carbons, therefore this should be butanamide. While this is a secondary amide, these 2 right here are tertiary amides. So whenever you're naming substituted amides, you need to make sure that the substituent that is attached to the nitrogen is going to come first. So in all of this, you can see that the name of the substituent that is attached to the nitrogen is coming first. Nomenclature of lactams. Lactams are cyclic amides, and they need to be named pretty much in the same way as we name cyclic esters. The general IUPAC name for cyclic esters is 2-oxacycloalkanone. But here, since we have a nitrogen group in the second position, it's going to be 2-azacycloalkanone. So let's go ahead and name these compounds. First, we'll look into the IUPAC name. This carbon right here would be 1 and this nitrogen would be 2. So you have to go in this direction where the nitrogen is present. And this would be 3, 4, 5, 6. it has got a total of 6 atoms. Remember, it's not the number of carbons. Instead, it's going to be the number of atoms that is present in the ring. So since it has got 6 atoms in the ring, it's going to be called a cyclohexanone. Since there is a nitrogen present in the second position, so it's going to be 2-aza-cyclohexanone. And for the next compound, this would be 1, 2, 3, 4, 5, and this would be cyclopentanone. And you have an aza group right there in the second position, basically the nitrogen present on the second position. So therefore, this is going to be 2-aza-cyclopentanone. And for this compound, 1, 2, 3, 4. So this would be 2-aza-cyclobutanone. Let's go on to the common names. For common names, we are going to use the Greek alphabets, right? And you have to go in the opposite direction. Look at these numbers. The numbers are going in the clockwise direction here, but the Greek alphabets are going to go in the opposite direction because you cannot assign this to be alpha, right? This carbon needs to be alpha. So for this one, it's going to be delta valerolactam. Why? Because it is the delta carbon that is connected to the nitrogen. And you have a total of 1, 2, 3, 4, 5 carbons, and therefore we have the prefix of valero. And for this one, this would be alpha, beta, gamma. So this is an example for gamma lactone. And since it has got 1, 2, 3, 4 carbons, it should be gamma butrolactam. Let's go on to the next one. So this would be alpha, this would be beta. So this would be a beta lactam. And let's find the total number of carbons. 1, 2, 3. So that would be beta propiolactam.